Good evening, everybody. Tonight, we welcome Dr. Beatriz Sánchez-Cano, an Ernest Rutherford Fellow and a lecturer at the University of Leicester, working mainly on planetary solar wind interactions. Beatriz did a PhD in Spain at the Universidad Complutense de Madrid, excuse my Spanish, with several long research days at the European Space Research and Technology Centre of the European Space Agency in the Netherlands, and also at the Abdus Salam International Centre for Theoretical Physics in Trieste, Italy. She then moved on to Leicester in 2014 as a postdoctoral research association, and then became an academic member in 2021. As well as her research work on the Martian ionosphere, Dr. Sánchez-Cano contributes to an array of space missions, such as the Bepi-Colombo mission to Mercury, where she is the guest investigator, and the Mars Express mission, where she is in co-charge of the radar ionospheric observations. So let's have a big Mexima and Swinton welcome for Dr. Beatriz Sánchez-Cano. Thank you.
Thank you so much. I hope, and I'm really sorry that I'm not in person with all of you. It has been a quite complicated week, actually. I'm really sorry, but I really hope you enjoy the talk. And of course, I will be more than glad to answer any question that you may have during the talk. So I'm going to talk about Mars, which I actually work with many planets, as Roy said before. I work with Mercury and even with giant planets. But I have to say Mars is it has a piece of my heart, because I did my PhD on Mars, and I continue, since that, I've continued working a lot on that, even to the point that I'm at the moment proposing a mission to the European Space Agency to characterize this planet. So today I will give you some insights about Mars, but specifically on how is the exploration of the planet, and actually if we can, in the future, we will be able to actually live and have humans on the surface of Mars. So hopefully you enjoy this trip around for the red planet in our solar system. So just to start, so why Mars? There is a lot of efforts at the moment that going in the direction of going to send humans to Mars. So first to the moon, hopefully actually next month there will be a launch from the NASA Artemis mission, but the next step for sure is Mars. And there is a lot of, even not only space agencies, but also private companies, really with the sight on our neighbor in the solar system. In particular, at home here at the UK Space Agency, there has been a huge investment in many missions, and in specifically on the European exploration program. So the goal is, we know there will be humans in the future at Mars. So the goal is actually advance as much as possible the research on that direction and understand the planet from the atmosphere, from the surface, and actually to what happened above, and how the planet actually evolved and maybe lose the atmosphere and so on. So our agency is strongly involved in that. But the question is Mars a holiday destination paradise, as maybe we hear on TV when other people and private companies, they really want to send people to Mars and so on? Is really that holiday destination? And I mean, this is a nice postcard actually that NASA made a few years ago, and I think it's quite nice. So Olympus Mons is the biggest mountain in the solar system, and it's at Mars. I will show you later a slide on that. It's actually super huge. It's more than 30 kilometers altitude. So imagine 30 is 30. I'm not inventing the number. It's really a huge mountain. You will see later. So let's imagine that in the future, maybe we will be actually with some telespheric like in here, just watching the planet. Who knows? So we will see today if this is just imagination or is actually close to reality. So let's see at the end of the talk, what do you think? So before starting and going into the material, I think it's very important to understand why we should explore the solar system. And I think I'm sorry to not see your faces, but I think the main answer is because we can, because the solar system is basically where we live. It's like, when you want to, you need some salt for your meals, so you go to your neighbor to see if you have a bit of salt, or it can give you some eggs or something. So let's imagine we can do the same in here. So we have a huge laboratory just at our next door, and each planet is actually really different to each other. So we actually have the opportunity to go and explore those worlds in order to actually get information that can actually help our own planet to understand our own planet, understand the physics of many phenomena that's going on in our own world. And this is basically what I said. So specifically, the comparative planetology approach is really the next step to actually characterize not only our solar system, but beyond our solar system, because we have a lot of analogs in other planets, in other systems that can be actually linked to processes that we have in our own home. So maybe Earth is a bit different. It does not have that right behavior and so on that we can see in other exoplanets. But maybe, who knows, maybe Uranus has, maybe Jupiter has, or maybe Mars has. So we have a home, our own laboratory that we should exploit in order to understand better the universe. But it's not like we are going to focus only on Mars because it's very close to us. To go to Mars, we only need 9 months, between 9 and 12 months. So it's quite close to us, but not because it's close, we want to study Mars. And actually, we have been in worlds much farther away. And if you like planetary science, maybe you are familiar with this picture. So I think it's a quite classical picture, but I like very much. And I'm really sorry I'm not there, because otherwise I will be asking all of you if you could tell me which world you're seeing here. But I will show you in a second what we have in here. But you can see in all these places that we have on the screen, so 7 different worlds. So these are real pictures, real pictures taken by spacecraft that have landed in all these locations in the solar system. And one of them is Mars. I don't know if you know which one is, but if not, I will tell you it's this one here where my mouse is, the one with reddish colors, with the sky reddish and so on. But you see, we have also landed on Venus, which is the one that we have next to Mars. It has this, sorry, actually, I apologize, it's not Venus, I apologize, oh my God, it's Titan, apologize. So it's Titan, which is one of the moons, actually one of the biggest moons in the solar system of the planet Saturn. So you see, we have landed in that, and also we see that kind of yellow sky, but also a surface very similar to what we see at Mars, and even what we can see at Earth, to be honest. And now, yes, Venus, sorry for that, Venus is the one on the left. You see that yellow color because it's full of sulfur. It's a quite, it's a planet quite intense with a high green effect on the atmosphere, really high pressure at the surface. And you can see that it's a bit smoother because the surface has been totally regenerated on the planet. And of course, I hope you see the ones between Venus and Titan. So if you have good eyes, you will see these characteristic crosses in here. So this is actually a picture taken by the Apollo astronauts at the moon. So you see again, is because the moon is towards gray colors, as we can see at night, but still the surface is very similar to all the other worlds, very rocky, with a lot of textures and a lot of different kinds of materials. And I hope you can recognize our own planet, because instead of choosing some surface, we chose the water. So we have liquid water and here on the right. But maybe you are less familiar with the landing on other bodies, which are not planets, and they are asteroids or even comets, as you can see here on the left. But we have actually landed on that. And I will put now here the name so you get linked to everything. So you can see, so the surface maybe look similar, but actually they tell us how they evolve and how the colors that they have, the components that they have, they tell us about different origins and about different kind of evolutions. So you see, at least we have been there, but there is much more places and there is much more to know in our solar system that can actually be a natural link to understand other systems well beyond our own location in space. So in particular, if we go towards the planets in the solar system, so from the point of view of that we are going to talk today, from the point of view of how the planets evolve in the larger scales, how the atmospheres evolve and so on, so we can classify the planets with different categories. So for instance, we have planets with or bodies with an atmosphere and a magnetic field, which you will see is essential for exploration. So we have Earth, of course, and we have also the big giant planets like Jupiter. Well, it's not here, but also Saturn and Uranus and Neptune. We have bodies with atmosphere but no magnetic field or near no magnetic field. So this is the case of Mars and Venus, and we are going to talk today mainly about that. We have bodies with no atmosphere and but with magnetic field. So this is the case of Mercury, which is a very interesting planet because it's very close to the sun, so it's highly radiated by the sun, but there is no atmosphere on there. Then we have bodies with no atmosphere and no magnetic field. So this is mainly the asteroids, the comets, the comets when they are far away from the sun or moon. And then we have a big, complex new system, and I say new because we have been exploring that quite recently from the last 2 decades, which are all the moons of the giant planet, which are itself as big as a planet, and they can have atmosphere or not, they can have magnetic field or not, but they are inside a very big protection, which is the magnetic field of the giant planets like Jupiter or like Saturn. So they are itself worlds quite interesting because we know they have water, a lot of water actually, under the ice surface that they have, and they are totally controlled by quite interesting physics. So who knows? We are looking for water and we're looking for life on planets like Mars, but who knows if actually we will find first life in these moons, which are a bit far away, but actually have different conditions that can help to see life in our solar system. So from all these planets, so why I'm today talking about Mars, this one here in the middle. So there are many reasons for that. I will say from the point of view of exploration. So we know Mars was formed at the time of Earth, and it has evolved. It's very similar, and it was very similar. We know in the past there was a lot of water at the surface, even oceans at the surface. But now it's dry and it's quite different, but still is in the limit of the habitable zone of our sun. So it has the conditions, or it had the conditions as well, for hosting life or hosting at least an evolution of an atmosphere and potential life as we had on Earth. And this is what I just said. So this is not a real picture. So this is a recreation of how we think Mars was in the past. So we know there was water in a very large amount of the planet, in a very large location of the planet, as we can see here on this recreation. So by understanding what happens to this water, so where is the water right now, by understanding that, we can actually understand how the habitability, so which are the requirements for habitability in our solar system, and then we can see if this can be applicable to other planets beyond our solar system, like exoplanets and so on. So these are the reasons, but of course this is like the scientific reason, but you cannot explore a planet if you don't have these things together. So this is a nice picture from NASA that I like very much, and I actually use that when I do teaching because I think it's quite representative. So we have an idea, we know what we want to see, so this is science, but we need the courage to do exploration. So okay, we have to propose a mission because we want to go to Mars and we want to study this, but you cannot do that if you don't have the right technology. And that's why the three things together, technology, exploration and science, you need the three together in order to go to another planet, even or to our moon and just beyond Earth. And I will show you a very nice example of that. So this is the picture, actually not that far away, it was only 136 years ago, of how Mars was seen by Schiaparelli from a telescope at the surface of Earth. So actually, it's not a very bad picture. Okay, you can say it's a bit old-fashioned if you want, but it's not very far away from the reality, because you see these nice canals, you see something in the north hemisphere is different to the south hemisphere. So there is something big here towards the center. So it's actually not that different to the reality. But this is the pure science and exploration. But when you add the technology, you can actually have this beautiful picture of Mars. That is a recreation of many individual pictures of the surface of Mars by Mars Express. And it's an image that was released for the 20th anniversary of this mission at Mars. So you can clearly see there are big structures in the middle. So this is a massive canyon, much bigger than the Colorado Canyon, which is the Valle Marineris. That most probably is one of these features that Schiaparelli saw here in the middle. And by the way, if you are not familiar with that, from this picture on the left is where the history of or stories of the Martians came from. Because Schiaparelli thought, oh, there must be people living on Mars, and because the planet is very dry, they are creating canals to bring the water that there is at the polar caps towards other parts of the planet. So this is actually the story of the Martians, let's say the origin. But we can see now actually there are no Martians there, or at least not that we know. But still the features are there. So there are big canals. The north hemisphere is quite smooth compared to the south hemisphere that is much older, full of craters. And you see the composition, the color is also slightly different because the composition is older and there is other kind of materials there. So this is what the technology does, and all together we can actually, so if we put all together, that's why we can improve our exploration and our understanding of the planet. So the history of Mars for exploration is quite long. So we started, as I said before, with these very nice telescopes from Paris Observatory, from London, Greenwich, from the big telescopes. And then we there to send some technology to other planets. So that was in the 70s with the Viking programs, with the Mariner programs, with the Mars programs. And then you can see here the evolution until now that even we have a helicopter at Mars. So you see in only, 140 years is not that a lot. I mean, if I think about that, maybe it's the generation of my great-grandfather. So it's really not that huge amount of time, but you see how the Mars or knowledge of Mars has transformed thanks to all this science, technology, and exploration together. And actually, there has been a lot of tries to go to Mars. So I'm not going to go into all the details on this picture, but you can see here, basically since the 60s, 70s, so the amount of missions that have been sent. At the beginning, it was mainly between the race between Russia or the URSS and the USA. But then later, other countries started to appear, like Japan, like the European Space Agency, like even now the Emirates, Japan, and India, and so on. But not all of them were successful. So you just see the first circle here in the middle. So these are failure missions, and only those that actually touch the surface, or they are in the second cycle, they're actually in orbit about Mars. So the majority of them actually were a failure, but we can only learn if we fail, right? So it's a learning process as well. So today I'm going to focus on two questions mainly for Mars. So the first one is, could Mars have one being habitable or will be in the future? And the other one is, what is the current feasibility for sending humans to Mars? So is that our next frontier? So is that holiday destination that I talked at the beginning? So if I start with the first one, like if Mars was once habitable, so I think everyone will understand that to be habitable, you need some ingredients like water and so on that we will see in a second. I just wanted to start with this meteorite. So this one is quite famous. So if you have a good memory, so actually I should have remembered myself how many years ago, but when Bill Clinton was the president of the US, actually there was an announcement that life were found in one of the meteorites from Mars, which is the one that you see here on the screen. Because they thought these features that you see here, this is a zoom of the meteorite on the left. So these features that they are here, they thought they were fossils of life from Mars. It was later demonstrated that it was not the case, because if there was something, we would not have survived or atmosphere and so on. And they said, no, this is not, it's something else. So it was demonstrated it was not at the end. But it just opened a new path to understand, like a new interest, if you want, on how we continue exploring Mars. Maybe there is life on Mars and we don't know. And actually, if there was life once on Mars, maybe these fossils should be seen in the rocks at Mars, maybe not in the ones that are actually coming from Mars to Earth, because everything will have been destroyed. So that was a first quite important step. And then also in our own planet, we know life appears in extreme conditions. So for instance, this is the very beautiful spring in Yellowstone, which is extremely acid, and if you know, it's it's full of sulfur and really strong materials. And even when someone unfortunately fell down, actually died almost immediately, right? So even in those conditions, we know there are bacteria, so we know they can survive in those conditions. So we know under the ice in Antarctica, where everything is extremely cold, we also see evidence for micro life on the ice. We see also even in like, for example, in Fukushima, or like in big after a big nuclear catastrophe. So we know even with radiation and with extreme environments in radiation, bacteria can appear suddenly, and we can have life. And also we know at the bottom of the floor, in extremely hot and extremely acid environments like hydrothermal vents, we still see bacteria as well. So another kind of formations. So we know in our own planet that life is possible to appear in extreme conditions. So why not on Mars? Okay, Mars is much colder than on Earth, but it may have the same ingredients that we have in our own planet. So to have life, we need three things. So this is at least life as we know on Earth. So we need access to biogenic elements. So this is typically carbon and other elements similar to that. We need a source of energy. So that's why it was very important that Mars is in the habitable zone of the sun. So that means it's in the zone that we think is warm enough for this potential life to appear, because the sun is very important. And also we need liquid water. Or we think we need liquid water, right? And of course on Earth we are full of that. So we have the ingredients, and that's why life could appear in our planet. But what happens in other planets? Because actually we know on Mars we have the three conditions that we see on this screen. And the fact is that there are many features and many signatures on the planet that show us that it is possible. So Mars is very similar to Earth. So I will show you now a few examples on what to look for when you're looking for habitability. So the first one is, of course, to look for those signatures of water. And I think by now everyone knows, because it appears a lot on TVs everywhere, but I will show you some pictures in here. So these are real images from Mars Express, from the high-resolution camera on Mars Express. And you can see these beautiful structures here, which are all rivers, or how to say, the place where the rivers were, but basically because there is no water anymore, but they are still there because they were formed when the water was continuously flowing through the surface. So the planet is absolutely full of them everywhere. But we also can look for water under the surface. And for instance, so as Roy said at the beginning, I work with one of the radars that we have on Mars, which is the radar MSAS. Actually, the work that I do is mainly focusing on the upper atmosphere, but however, the radar is there to actually look for water under the surface. And you see with the radar, it's like a geophysical radar. So when you're looking for pipes and so on in a construction place, it's the same, but in this case, we are looking for water. And actually, we know, specifically in the south hemisphere of the planet, near the polar cap, that there are potentially deposits of water, as you can see here. So these are radar observations. And this white part in here that is a bit brighter, specifically where the blue points are, is where we think the deposit of water they are. The problem is that they are quite deep, so 1.5 kilometers, which is going to be hard to go there and to get. But the thing is that there is liquid water there. And also, hopefully, in a couple of years, so we will have the rover ExoMars, the Rosalind Franklin rover from the European Space Agency, which we will have a drill of 2 meters. And with this drill, we are hoping to actually go deep into the surface, to the pristine surface, because radiation and the lack of water affects a lot the formation of the rocks and the evolution of the rocks at the surface. But by having a deep drill, in this case 2 meters, we can actually go to a pristine layer of material that may have not only water, but may also have signatures for past life on the planet that has not been destroyed by the radiation of the surface. So this is how to look for water signature, but also we can look for something else. So we can look to see how active the planet is. And with that, so we had a few years ago, unfortunately, this rover stopped operating relatively recently. So this is the mission InSight from the NASA that has a seismometer. And with that seismometer, we could actually see that Mars has Marsquakes. You may not believe that Mars is alive. It actually moves and it has activity. And you can see here on the left, the signature of one of these quakes at the surface. So you see the main signature of the wave, the primary wave, the secondary waves, and then this is all the frequency, how it moves the waves, and actually we can understand better the interior of the planet, if there is a core, if there is a liquid core, and so on. So what else about habitability? So you may think this has nothing to see with Mars, but actually all the opposite. So this is actually what I do for my work at the university. And it's a pity it's not working. Okay, I will do like this because I think the video is not working. So I will move like this. So what you are seeing on the screen is the sun. However, we have created an artificial eclipse on the sun. So we have like a cover to cover the surface of the sun, which is these circles that you see in here. So actually, the white line, it means where the sun is, and then we are covering a bit of the region. Why we do that? Because as during a solar eclipse, so we want to see is actually the atmosphere of the sun. So this, what you see here surrounding this cycle is the corona of the sun or the atmosphere of the sun. So if I move the video like this, hopefully you can see like it's continuously emitting big portions of material. You can see here how it came from the sun and how it moves and expands away. So these are what we call coronal mass ejections. So these are big ejections of plasma from the sun. And what happens, so this is like a massive radiation storm coming from the sun. And they propagate, these particles that are ejected from the sun, they propagate through the solar system. And you can see actually the planets in here, how tiny they are compared to this massive, you see the green area in here is the part of these particles, which is really massive. So when these particles arrive to the planet, so they create radiation storms, and actually they do much more than that. They actually erode the atmosphere. And you can see, hopefully this video will work. Yeah, it works good. So you are going to see in here, so this is Mars, and all these particles that are bombarding the planet, this is what we call the solar wind, which is composed of all these energetic particles from the sun. So it's continuously bombarding the planet. Sometimes it's more intense, sometimes it's less intense. And you can see now a graphic of how actually we measure that with a spacecraft called MAVEN. So we measure the break of these particles with the atmosphere of Mars, how they erode the atmosphere. And actually you don't see that in here, but the atmosphere escapes. And this is critical because if the atmosphere escaped, the atmosphere became thinner. And if it becomes thinner, the atmospheric pressure becomes lower. And that means the water, there is a moment in which the water cannot be anymore in liquid format because it will be, if you know, the triple point of the water. So it will never be, again, it cannot pass from gas to liquid to solid. It will automatically pass between gas and solid, but not on the liquid form. So this is literally produced by the sun. And I will play again the video so you can see again on how the sun and this massive bombardment of radiation from the sun actually erode the atmosphere and make the atmosphere to be lost into space. So this happens all the time. It happens also at Earth. But at Earth, we have a magnetic field, as we saw at the beginning, that actually creates a kind of a small protection. There is still escape, but it creates a small protection for the atmosphere to be preserved. So this is the first part. So if I go to the second part, which is the current feasibility of sending humans to Mars. Now you know about the planet, so you know how the planet behaves. So let's see if actually we can make Mars our home. So Mars today is quite dry. and very cold. It's really, really cold. So just at the equator, maybe it could be a few degrees over zero Celsius, but it's literally all the time everywhere on the planet with significantly below zero in mostly all the latitudes. Especially at the poles, it's really, really, really cold. So it's a very cold planet, but also it's dry. So there is no liquid water. You will see in a second, actually, there is water in the form of ice and in the form of water vapor, but not as a liquid form. However, we know in the past it was. So as I said before, we have all these canyons, which are beautiful, and they are the signature that in the past there was. So that means the atmosphere has been lost into space. Also, another characteristic of Mars is the dust on the planet. So Mars is totally governed by the motion of dust and by the cycle of the dust. So on the left in here, you see a picture of Mars in a very nice day, actually, with the polar cap in the south hemisphere, and a very nice picture. But you can see on the right what happens when there is a global dust storm. So this typically happens, so the dust storm season occurs when Mars is closer to the sun, because the orbit is a bit elliptical. So when it's closer, there is more radiation from the sun, it's warmer, and then the dust becomes alive. And sometimes it's regional, but some other times it evolves and actually get the full planet. And you can see in here, it's so intense that you don't see the features of the surface. You may see a bit the polar cap, but it's not really possible to see the features of the surface. And when this happens, it's like that for many months until the dust storm dissolves. So why I'm showing this? Because you will see this is essential for exploration, not only because there is no radiation, there is no light from the sun reaching the surface, because the dust totally creates like an opaque layer on the atmosphere, so it's night permanently of Mars during these events, but also because it enhances the loss of water. So do not worry about this graphic. I will explain you what it is. Do not worry about that. You can see here at the top. So you see there is a mountain here, the Olympus Mount, and then 3 mountains here on the first figure. And then during the dust storm, you see it's more difficult to see them, right? So this is just optical images on the evolution of the dust storm. And what we see here on the bottom panel is actually, so you see the blue colors in this panel in the middle. So this is the amount of water vapor that we have in the atmosphere. And you can see, and actually quite high in altitude, even up to 1,000 kilometers, so very, very high, just touching the space, okay? So you can see like the lighter blue colors occur at the same time as we have the dust storm, when we don't see almost the mountains with the dust suspended in the atmosphere. So dust increase the concentration of water vapor because of chemistry and because of other stuff, makes the water to move up, and then the solar wind arrives and then takes the atmosphere out. So this is a mechanism that we have found recently, that during this dust storm that happens every year, there is a significant amount of water being lost into space. So the atmosphere became thinner, and then we start the process again. So the dust itself is really the main mechanism at the moment at Mars controlling on the dynamics of the planet. And it's not only like the dust favors the water, and there is water when there is dust. So we actually have a water cycle, so which is similar to the cycle that we have on Earth, but with the difference, it's not because of the rain and so on, it's because the polar caps sublimate. So again, do not worry for this graphic. I promise it's the last one, but you see here, it shows a map of Mars, latitude on the y-axis, and then what you see on the x-axis is just one Martian year. So you see there is like a region in red here near the polar cap, near 90 degrees. So this is when Mars the North Hemisphere is in spring and summer. So it's warmer there, and then the polar cap sublimates. So it does not go to water, it directly sublimates, and the mass of the atmosphere rises, and there is more water in the atmosphere. And then the same happens when it's summer in the south hemisphere, you see here, but it's a bit less intense for other reasons, but still the south polar cap sublimates. So there is a cycle of water, even if there is no liquid water at Mars. So that's important to know, especially if humans will be there in the future. And of course, by now you should know there is water, a lot of water at the polar caps. Is water and carbonate water, so because of the atmosphere is CO2. But this is a nice picture from Mars Express, where you can see the northern polar cap very, very nicely. And also, it's very difficult for liquid water to be at the surface of Mars because we don't met with the pressure of the atmosphere. It does not meet the conditions to reach the triple point of water. However, it can happen under very peculiar circumstances, like a very particular circumstances, like for instance, when the gullies are formed, like you see here on this picture. Sometimes we see from one picture to another one, we see that has been some slopes that have moved, let's say, and we think it's because of particular moments in which there was liquid water at the surface. Or, for instance, we see water droplets. Actually, so we see that this is the Phoenix lander from NASA that landed in the North Hemisphere, and in the shadow and in the legs of the rovers. So you see there were some water droplets in there. So under very particular circumstances, it can be liquid water, but very unstable. And also, of course, I saw already a picture, but I will show a bit more. We have evidence that has been liquid water everywhere on the surface in the past. So this is another picture, very nice craters here. And then you can see all this older terrain. So you see the craters are new terrain because they are totally flat, like no craters. But then you can see outside the older terrain with all these structures, which are clearly water flowing in the past in the region. So the same in here, same in here, the same here. So this is actually a nice crater in which we also have some kind of like a mountain in the middle and evidence of water flowing around. So we see that this is a picture from a rover, actually. So you can see the slopes here in the terrain, as I showed before. And even we know there is a lot of gypsum on the planet. If there is gypsum, as you may know, it has to be water, otherwise the gypsum cannot form. And it's basically everywhere on the surface, at least in the older surface of the planet, in the south hemisphere. So this is what we know happens with water. But also another evidence to have water is if you have volcanism. So it's actually it links actually directly to also water. And actually, we know there are big volcanoes on Mars. I said before, the Olympus Mons, the one that we can go to explore in our holidays, is this Mons in here. Just the color scheme in here is altitude. So the blue means lower altitude, the red color, yellow colors, and the white means higher altitude. So you see these nice Olympus Mons and these three massive volcanoes that we have in here. So this is the area called Tarsis, a very big area mountain. And I said before, so these three mountains come together with Olympus Mons, so they are about 30 kilometers altitude. And I'm not inventing that, I'm showing you here an example. So in blue, we have the Everest Mount on Earth, so 8 kilometers, a huge mountain, right? On the left, we have the Mauna Kea in Hawaii, that over the surface is only 4 kilometers, but actually, if we count the sea floor, it's about 10 kilometers. So you see, it's a quite big mountain, but we see in the background the Olympus Mons. So this one that we saw here, 30 kilometers altitude in a planet that is smaller than Earth. So you may imagine the amount of not only water itself, but actually gravity waves that can produce and so on. So it's really controlling also the planet itself. These volcanoes, which are actually relatively new. And also for sure, we know that Mars was wetter in the past. So probably it looked like the picture on the left. It's a recreation, the picture on the left, the picture on the right is a real picture. But probably it looked like that in the past. So it was warmer for sure, there was water, so there was more regulation, so it was warmer. And who knows, maybe there was also some vegetation that now we don't find any signs at all of that. So where has the water gone? That's a very big question. So I'm sure it has left to space, but why? So this is the big question that we are trying to answer. And the question now is, so we know how Mars is now. So we know how Mars was in the past, but how Mars can be in the future. So is there any way in which we can actually terraform Mars as big people like the SpaceX companies and so on, they plan to do or they want to do? Is really possible to transform a dry planet and a cold planet to a wet and warmer planet? So the question is actually very complicated. And I will give you some insight on what you will need if you want to terraform a planet. So I started this talk talking about the magnetic field, which is very, very important. Why is important? Because the first step to have an atmosphere is to be sure you have a magnetic shield. Because you have seen how the sun, the particles from the sun interact with the planet, right? So here on the left, we have our planet, we have Earth, and Earth has a very good magnetic field, so it's quite intense. And you can see here with these yellow lines. So this magnetic field interacts with the sun, is on the left on this picture, and create our magnetosphere, which is kind of our shield protection for this radiation that came from space. On Mars, which is on the right, so but for planet non-magnetized, so there is not that magnetic field. So instead, we have the particles from the sun touching the atmosphere. So the radiation is much larger. So if we want to send humans to Mars, we need to send them protected for the radiation because there is not that magnetic shield that we have on Earth that can protect the life to occur. This is why we need a drill to go below 2 meters because the rocks has been totally radiated by the radiation. So if there was life, it's totally eroded by this radiation. So the first step is to have a magnetic field. And to have a magnetic field, you need an active core in the planet. So it's a quite complicated scenario. So also, we need the right components in the atmosphere, right? So here on the right, we have Earth, or an atmosphere, which is nitrogen and oxygen, right? And we breathe the oxygen, but also we breathe a lot of nitrogen, which is essential because oxygen is very corrosive. We have a lot of trace gases, which are essential also for the life. But however, on Mars, the majority of the atmosphere, the 96% of the atmosphere is CO2. So it's not a gas that we can breathe. All the life may be able to breathe, who knows? I mean, we know it can, but maybe not all types of life. And there is only 1.9% of nitrogen. And then there is oxygen, but it's actually more in the upper atmosphere than at the surface. So this is the composition. So we need a warm atmosphere. And at the moment, Mars does not have a warm atmosphere. It's quite cold because it does not have the right ingredients that Earth has for the atmosphere. Also, if we want to live on Mars, I think it will be ideal to not be all the time with a spacesuit and with an oxygen bottle with us, right? So otherwise, we need to live confined in very limited space, right? And who knows, this is a picture from the movie The Martian, and who knows if we can actually even grow our own potatoes in there. I'm not really sure of this because who knows how is the water and if we can have actually water there if the atmosphere is not enough. So anyway, so I think this is the step that will be ideal, but I think we are a bit far from that. And to be honest, is this feasible? I think maybe this is a question that we can discuss later. I think, in my opinion, it can be, but maybe in 100 million years, because if we don't have the magnetic field, then we have a big problem. We don't have the atmosphere, we have a big problem. So I think for that, it's going to be complicated. And I mean, it could be possible, but not with the technology that we have right now. And we have the science, the technology, and the exploration. So if you don't have the technology, we are missing one particular part for that. So I just want to finish. I have 2 slides more or 3 slides more is just to finish. So at the moment, we are doing a lot of efforts in order to understand the evolution of the atmosphere, because it's essential for understanding the habitability of the planet, but also for the future of the planet, right? So I just wanted to let you know, like NASA, it sent in November 2 spacecraft, very small spacecraft to Mars with the goal to understand the escape. Actually, the mission is called Escapade, because we want to study the escape of the atmosphere. And actually, I want to show you that myself, I'm proposing a mission to the European Space Agency, which is called MSAS. And actually, you can see here, it means Mars, magnetosphere, atmosphere, ionosphere, and space weather. So it's literally to understand this evolution of the atmosphere with the space. So in space, sorry. I have in here a small simulation, so you can see, so these 2 spacecraft moving around the planet, and we want to study all this part here in green and orange, which is literally all this atmosphere that is interacting with the sun and is potentially escaping towards the tail of the planet. So this is a simulation just to show you how the 2 spacecraft are going to characterize the planet. And I think my last slide is this one in here. So can we make Mars habitable? I think this is a question for all of you now. I already told you my thoughts. I think it's possible, but maybe what is more possible in a short time scale is actually this picture that we're seeing here. I'm sure we are going to be able to send humans to Mars. I'm sure we are going to be able to create some kind of stations of this kind. The other way, if we can terraform the planet, I think that will be more complicated. I think it's possible, but not in our lifetime scale for sure. But maybe this is how the future will look like. I don't know. It looks like we are going into that direction, both with the moon and with Mars. And I think with this, I will just finish here my talk. And I think I need to remember that the microphone is closed from your side, I think.
Beatriz, thank you very much. Thank you very much for a very entertaining evening. And could I ask everybody to join with me in giving you a big Mexican Instrument and Astronomical Society? Thank you. Thank you very much, Beatriz.
Thank you so much.